Hello students! Today's video is our first day of surface area of a rectangular prism. I can even have that title here, surface area of a rectangular prism. Now the cool thing is you already know what a rectangular prism is because we've already done volume of rectangular prisms. But when I talk about surface area, like what the heck does that mean? You know volume is the amount of space a three-dimensional object occupies. But what's surface area? Well, check out this little box I made out of paper. So I made this little three-dimensional rectangular prism. It's not very great, but when you think about a box, right? So say this box is sitting there. The first thing I want you to think about is how many sides or faces does a rectangular prism have? Think about that for a second. How many sides make up a rectangular prism? Well, let's see. We have the bottom and the top. We have the front and the back. And then we have the side and the side. So altogether, we have 6 surfaces. So it's really easy, guys. We're just going to find the area of each surface. And by the way, each surface is just a rectangle, 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 rectangle. We're going to find the area of each of the 6 surfaces and add them together. And then we'll have the area that our surfaces cover, surface area. You could even look at something like a tissue box. Now, this is a little messed up here. Just pretend this was covered with this cardboard, right? Tissue box, right? 6 sides, 6 surfaces. There's your bottom. Pretend your top is covered, you know, your front and your back, and then your 2 sides. So that's what we're going to be talking about today, finding surface area of rectangular prisms. So take a look here. There's a formula. And if you look at your yellow formula sheets, you're going to see, I'll even go get one. Let me go grab my formula sheets. So if you look on the right side here, you're going to see for a rectangular prism, we've already studied volume, that's done. Here's your surface area. So that will be there for you. And I also have it written here. But I'm a big Y person, so we need to talk about where in the world this formula came from. Once we do that one time, I won't make you do it again, but you gotta understand this in case you ever have to rebuild it, in case you don't have your formula sheet. Like, what would you do? It's actually very easy, guys. So take a look here. So here's your rectangular prism, just a generic one. You know this measurement here is the length. So I'm gonna call this L for length. And this over here is my width. And then of course, the tallness is the height. And there are the 3 dimensions. Okay, so where does this come from? Well, we talked about just a minute ago when I was showing you my prisms. So we have the bottom, right? And then when you think about the bottom here, sort of a mirror image of that bottom is the top. They have the same dimensions. So I'm gonna lump them together as bottom and top, okay? Let's just take one at a time. Let's start with the bottom. Let's find the area of that surface, surface area, the area of that surface. Now let me make that another colon. Okay, the bottom. Area equals, well, let me color in the bottom. Here's my bottom, right? Highlight that in. And that's a rectangle. And the area of a rectangle is length times width. And you can see length times width. So the area of the bottom is going to be L times W. But we don't just have a bottom, we also have a top. Color that in as well. But the top will have the same dimensions as the bottom. It will have length here and width here, and it will mirror the bottom. So when I'm talking about the area of the bottom and the top, I'm thinking we have 2 of these, 2 times length times width. You could also think of it as adding like terms. If you take length, width, plus another length, width, 1 LW plus another 1 LW is 2 LW. But most people just think of it as two surfaces, each at an area of length times width. Okay, great. I'm going to move this box here. Okay, let's move on. Now we have a front and a back. And by the way, let me highlight this guy here. Okay, let's talk about the front and the back. So, front. And I lump them together because they mirror each other. Okay, so we're looking at the front and the back. Now, what about, let's take the front first. Let's take the front. Let's talk about the area. So we need to know the two dimensions on the front. So let me get a different color highlighter here and let me color in the front. So here's your front. And those dimensions, again, it's a rectangle, so we have to take this length times this dimension. Now this dimension is this dimension. It's the tallness, which is height. I could bring that height here. So length times height will give me the area of the front surface. Length times height. But we have the front and the back. The back here, this part here would be colored in as well. This would be the back. That side there would also be length times height. We have two of them. So let's say that the area of the front and the back is 2 times L times H. And finally, we have these sides, right? We have these sides. So let's call it side and side, but we'll just take one of them at first. And we need that area. So let's take a look. We'll make this green. So here's a side. And the other side's over here. What are the dimensions there? Well, we're going to have to multiply this dimension times this dimension. Width, W times height. So W times H will fill out all this space. So area, W times H. Get the two sides together and we'll have area equals 2 times W times H, because you have those mirror images. So how do you find the total of all 6 surfaces? Here's 2, 4, 6 surfaces in a rectangular prism. Well, you simply add all the areas together. You add the bottom and the top to the front and the back to the two sides, and guess what you get? This formula. There it is. 2 of these plus 2 of these plus 2 of these. This is the bottom, top, front, back, side, and side. So cool. Now, using it is what you have to do. So let's look at our example, and this will be the last thing we do in the video. Okay, this example says, find the surface area of the rectangular prism. So they've given me a rectangular prism that is 5 units for L. Let's call that L. And it is 3 units for W and 2 units for H. Now, I'm going to show you how I would set this up because you want to keep your work organized. So the first thing I would do, guys, is I would write, let me actually get a darker marker here. Okay, that rhymes, darker marker. Okay, so let's call L. I would list it out. Like first I would say L equals, W equals, H equals. List them out. So the length is 5. Your width is here 3, and your height is 2. Okay, get those in line. Now, your formula. You know SA, surface area, equals, let's say 2 times, and then you know there's 2 dimensions behind here. So I'm going to put 2 boxes there. Then we're going to add 2 times another 2 dimensions, and finally 2 times another 2 dimensions. I would set that template up. Now, all you have to do is fill the correct numbers in. Now, here's my next trick, if you want to call it a trick. Now, if you're looking at the formula, that's fine, because you can just fill it in. But if you would lose your formula sheet or not have it, I always do it like this. So this guy right here, I always start at the top, L, and then I put him with width. So it's kind of LW. Then I do LH because I take L to H. So I sort of exhaust my length. I put length with width, length with height, and then I move down 1 and put the width with the height. WH. LW, LH, WH. And then you just fill them in. So our length is 5, our width is 3, our length is 5, our height is 2, our width is 3, our height is 2, and off we go with a calculator. Not that you need a calculator, you can obviously do this in your head, but since we're using it this unit, you can really you should be able to put this whole thing in just as is. So 2. Let me bring this down a little bit so you can see it a little bit better. 2 times 5 times 3 plus 2 times 5 times 2 plus 2 times 3 times 2. I'm getting 62. So this is going to be a final answer. Surface area equals 62. They just called it units. Units. And since it's area, surface area, these are all 2 dimensions, right? Length, width. If this was centimeters, centimeters, or inches and inches, it would be inches squared. So surface area, we're back to squared, not like volume where you do cubed. And that's it. So you're gonna do some practice now on surface area, but the truth is you only need these 3 numbers, you need this formula, and you need your final answer. Good luck.